we were gonna start. Anyways, so step by step, because after this we start tolerance. Okay. So the circumference of, there we go. As I was saying, we'll wait for that to warm up. Technical difficulties. There we go. 0.1 centimeter is the precision for the first. There it is. And therefore the uncertainty is half of that. So sorry, 0.05 of a centimeter. So you get a mark, right, half and half for that. The precision for this particular measurement, based on the number, it's down to the nearest 100th of a centimeter. And therefore the uncertainty is half of that. So you get 1 mark for that. Watch the zeros, right? The weight, in this case, we're down to the 3rd decimal. So we put that 1 in for the 3rd decimal and make sure you have units always, okay? Uncertainty is half of that, which is 0.0005 kgs, kilograms. And here's where I'm going to zoom in a little bit. Okay, so you have to figure out the precision based on the increments. So it goes from 10 to 20, but in between you have markings. Right? So I think it's 2, 4, 6, 8, 10. So we're going up by 2 every time. So in this case, it's actually 2 psi to get from one number to the next. Right? There are 5 spaces in between. 1 second. There it is. And therefore the uncertainty is 1 psi. What do we measure psi in? Pressure, your tire pressure, right? That's psi, pounds per square inch. And next we have the beaker here, and you should notice that you're going up by 10 every time, right? Right? 30, 40, 50, 60. So we're going up by 10. So my precision is 10 mLs, okay? And my uncertainty is 5 mLs, right? That happened, what I predicted was going to happen. There's a paper towel up there. All right, precision is 0.5 of an inch, sorry, 0.1 of an inch, 0.5 is what we go by. So the uncertainty is 0.05 of an inch. So the measurement with its uncertainty, you need to state it like this to get full marks, okay? Is plus or minus 0.05 of an inch. This is what I'm after. Hint, hint, right? This one is going to be a bit controversial, but I allow you to do this, okay? If you don't like the quarter of a foot, just go 0.25. So the precision of that is 0.01 of a foot. I will do the fraction in a bit, so if you're waiting for that, just hold on. 0.005 of a foot is my uncertainty. Yeah. Oh, you just went straight to, that's fine. I would just be careful. Because usually when we rush, we get it wrong, right? But if you're comfortable with it, sure, jump straight to the end. No problem. So 14.25 of a foot plus or minus 0.005 of a foot. That would be the correct answer if you stuck to decimals. So here's your fraction. The precision here is to the nearest quarter foot. Okay, so the uncertainty is half of that, which is 1/8 of a foot. You double the denominator. So that would be 14 1/4 feet plus or minus 1/8 of a foot. So that is the, if you prefer stating it as a fraction, that's fine. You can go either way. I'm okay with that. Here the precision is 0.001, right? Because we've got 3 decimal places, and the uncertainty is 0.0005. Okay, and so the actual measurement is don't drop zeros in this unit, right? If the measurement is like that, it's there for a reason. So try not to do that from now on, okay? So this one has 0.540 millimeters plus or minus, right? You've got to have 4 decimals on the uncertainty there. 1 mark for each correct final answer there. And then here, your precision is 0.1 of a second. Okay. And the uncertainty is 0.05 of a second. Therefore, the measurement is 4 minutes, 23.5 seconds, plus or minus 0.05 of a second. And I always have a few students say turning everything into seconds, and that's fine if you did that. If you turned your 4 minutes to seconds and then added, and your final answer is everything in seconds plus or minus, that's fine. No big deal. Precision here, 2 decimal places, so it's 0.01 of a meter. And so the uncertainty is half of that. Right? So it's 350. Don't drop these zeros. If you did today, that's fine, but moving forward, I want you to keep them. So it's 350 plus 0.005 of a meter. That doesn't look like a meter, does it there? So this page is 10. 5 and 5, 10. So hopefully by now you have a pretty good idea of what is expected in those scenarios. And here's where the backside is where it really comes down to, do you really understand what's happening? So which beaker is more precise? Explain, show your work to earn marks. So you can't just go like this one, right? So this is what I want you to do. For every single beaker, this would be one way of showing your work, is show what your precision is, right? So here, I can clearly tell that this one is going up by 100. So the precision of that beaker is 100 milliliters. This one, it's hard to see, but you're going from 40, right? So this must be 60, 80, 100, 120. So the precision of this one is 20 milliliters. And then this one, I have to make that bigger. It's pretty small. So I apologize for that. This one goes up by 50 milliliters. There are no markings in between. So the precision for each beaker is stated. So this is the one. Beaker B is the more precise. Comma, since it has the smallest increments or increment. Okay, it has the smallest increment, or you can say it has the smallest precision. I'm okay with either one. But whichever one goes up by the smallest amount is always going to be the most precise. Okay, and usually it's the smaller item, right? Like usually when you're measuring liquids and stuff, because you have less, so obviously means that you really want to get it right. You're not mixing a couple of liters, you're just mixing, it goes up to 80, right, or whatever, 100 and something. So next, so 2 marks, 1 mark for the work here, and another mark for picking the right one and telling me why you picked it. Okay. So watch out for those ones. They do show up quite frequently. A welder is welding 3 pieces together. You're welding 3 pieces together to strengthen the bottom of a trailer. He buys 3 pieces online and knows that they measure as follows. State the precision and uncertainty for each piece. So I'm going to do it this way, 3.2 feet. The precision is 0.1 and the uncertainty is 0.05. You get 1 mark for that. I take the next one, 2.75 feet. The precision is 0.01. The uncertainty is half of that. You get a mark for that. The third piece measures 4 feet. The precision is 1 foot, right? There are no decimals. Uncertainty is 0.5 of a foot. So 1 mark for each correct precision and uncertainty for every single piece. And remember, it has to be exact. It can't be close enough. Like, oh, I just missed a 0. It's a big deal in this unit, actually. So now it says, calculate the combined length of the pieces, so all the pieces, including its uncertainty. So you're basically going to add up all of these, and I allow you to just state that here. What is it? 9.95 feet if you combine all of their lengths, plus or minus. If you combine all of the uncertainties, if you add them all up, you get 0.555 feet. So you get 1 mark for this and 1 mark for that done correctly. Now, if you got any of these wrong up here, of course it's going to carry forward here. I would not take away another mark. I would say step check, right? Because if I notice that you added these up, you know what you're doing. You made a mistake up here, and that's it. You just get penalized up there, not down here as well. Calculate the combined maximum and minimum lengths. So the max is simply 9.95 plus 0.555. The min is 9.95 minus 0.555. So you just add and subtract, and what you get is this, 2.505 feet. And if you subtract, you get 9.395 feet. You get 1 mark for each. Now, you're going to say, Mr. Jackson, do I lose marks if I get a different answer here? And the answer is no. If I see that you're adding these two to get your max and you're subtracting to get your min, you get the marks. We carry it forward, okay? Next, we have, you know what trim is? I forgot to mention that. What's that? But if you're installing a piece of trim, it's actually like at home you have, like, you see the gray little border, the gray piece along the bottom. In our homes we have wood, right? We have like a profile piece of wood kind of hiding the imperfections, and you have it around the door frame, right, to hide. Like, that's trim. Okay, I don't think it was a big deal not to know what a piece of trim is in this case, but you're cutting off, exactly. So 2.4 meters for the piece of trim. I will quickly mention my precision and the uncertainty. For some of you, this is like, yeah, I get it. Right, 0.5 is what you're cutting off. And that's your uncertainty because it has 1 decimal. And this is my uncertainty, that's my precision. They both have the same precision and uncertainty. So what I do is I subtract and I get 1.9. I forget about the precision. That should not be part of your final answer. Plus or minus, you add these up, regardless of what happens up front. So you get 1 mark for this and 1 mark for that. And that's your final. Okay. 1 mark for each. Now I'm curious to see how you did this one. If you measure 50 pieces of wood and they measure this with their uncertainty, right? This is the uncertainty. What would be the combined uncertainty of all pieces? And the answer is 50 pieces times whatever the uncertainty is for every single piece, right? And so that's 0.50 centimeters. 1 mark for that. Because it's like you're adding 50 pieces, right? So they all have their uncertainty. So in that case, you wouldn't add, you would just multiply, right? As many pieces as are being measured. That's what you would add there. So this page is 12. This back side is worth 12. The front is worth 10. So 10 and 12, 22 total. So add it up. Put a total at the top.